Hi, in this question, we are going to look a problem where we can make thorough of our concepts. So, it's given that it's a series RL circuit connected across a 220 volts 58 supply. So, first of all, we will just draw the circuit RL in series with voltage source of 220 volts 50 hertz. R is given, L is given. What is R? 15 ohms. What is L? 0.25 ohm, not ohm, Henry. Okay, now we have to find XL, the reactive impedance. What is XL? 2 pi FL. Okay, what is frequency? Frequency is given as 50 hertz. What is the inductance? 0.25. So what will be XL? 78.54 ohm. Okay, so when looking at the first part, we have to find the total impedance. Total impedance means Z. What is Z? Root of R square plus XL square. What is R? R is 15 ohm. 15 square plus 78.3454 square. Right. Okay. What will you give the what will be the answer? Answer will be 79.96 ohms. So this is the total impedance of the RL combination. So we completed the first part. So what is the second part? In the second part we have to find the current through the circuit. What is current through the circuit? We have a series circuit. We have the total impedance as set, and we have the total voltage across the series combination is V, voltage to 20 volt RMS. So I is equal to V by Z. V is 220 by 79.96 ohms. What will be the answer? The answer will be 2.75 amps. We got the current. We got the current. So what is the next part? We have to find the voltage across the resistance. We can call that as VR. What is VR? Current into resistance. That's how we calculate the resistance. So from the circuit I can say that the current is same for both the R and L. We got the current 2.75, and what will be the voltage across this R and R if we connect a voltage source like this, right? So if you connect a voltage source like that, a voltage, sorry, what, not a voltage source, a voltmeter, we get VR. What is VR? I into R. What is I? 2.75 amps. 2.75 into resistance is 15 ohm. So the answer will be 41.27 volt. So this 2.75 is the RMS current into resistance, right? So what is the next part? The next part is voltage across inductance. We call it as VN. If you put a voltage meter, say voltmeter across inductor, what will its reading? Okay, how will we calculate? We can calculate like I into XL. So what is I? 2.75 into what is the value of XL? XL is given as 78.54. So it will be 215.98 volts. Okay, right. We got the voltage across inductor. Now the fifth parts, the interesting part, we have to find the power factor. We already know it's an RL circuit, so the circuit definitely will be a lagging circuit, right? So we have to find power factor. Power factor cos phi is equal to R by Z. What is R? R is given as 50 ohm. What is Z? Z is 79.96 ohm. So what it will be the value? It is 0.1875. Power factor is 0.1875. We got the value. So what is the sixth part of the question? What is the sixth part? What is the sixth part? Phase angle between voltage and current. We have to find the phase angle. In our RL circuit, the phase angle will be the power cos inverse of that power factor. So phase angle phi can be calculated as cos inverse of PF. Right. What is cos inverse of the PF? Cos inverse of 0.1875. It is 79.18 degree. So we got the phase angle between voltage and current. Then what will this active and reactive power? Simple. What is active power? P PRMS into IRMS into cos phi. So voltage is given as 220, current is 2.75, cos phi is 0.187. So what will be the watts power consumed? Active power will be 113.49 watts. Okay, done. So what is the reactive power Q? Reactive power Q is IRMS into sin phi. What we have 220 into 2.75 into what is sin phi? Sin into cos inverse of 0.187, right? Okay, you understand the concept now. Phi is equal to cos inverse of 0.1875, sine of cos inverse of 0.1875. It will give our qua reactive power Q. What is the value of reactive power Q then? 594.25 volt ampere reactive, because it's a reactive power. So the unit is VAR. So next we have to find the apparent power. The apparent power, which means the phasor sum of P and Q. Either we can calculate like root of P square plus Q square, or we can calculate like voltage PRMS into IRMS. It's actually simple using VRMS into IRMS here. 220 into 2.75. What is 220 into 2.75? It's actually 605 volt ampere. 605 volt ampere. Next part is the question is equation of instantaneous voltage and current. So we all talk about the RMS values of voltage and current up to question 7. Now we have to talk about instantaneous value. Instantaneous value means small v is equal to Vm sine omega t. That's the general form, right? Sine omega t. This is the regular form. So to get Vm means maximum voltage. So from RMS voltage, what is the definition of RMS voltage in AC? Vrms is equal to Vrms is equal to Vm by root 2. So what will be the Vrms into root 2? Vrms into root 2. So here 220 into root 2, which is 311.2 volt. So it's the Vm. Now we have to find omega. Omega, what is omega? We have the frequency here. How to convert frequency to omega? Omega is equal to 2 pi f. So we can substitute 2 pi into 50. It's a frequency, which means 100 pi is equal to 314 radians per second. That's the unit of omega. Omega. Now we got Vm and omega. Now how we write instantaneous value of V voltage? We have to use small letter V is equal to Vm. What is Vm? 311.2 into sine of it's a sine voltage omega t 314 t. Okay, this is the instantaneous value of voltage. This is the instantaneous voltage of equation of voltage. Now we have to find the instantaneous value of current. So what will be the equation? Im sine omega t. If you are talking about a resistive unity power factor circuit, it will be Im sin omega t, but we have an RL circuit, so definitely there is a phase angle. We already found the phase angle here. It's 79.18 degree. Means the current is lagging behind the voltage by some degree phi. So the general equation will be sin omega t minus phi, right? So we have to find Im. What is Im? Similarly, for the voltage, what we do in voltage, we multiplied IRMS into root 2. So 2.75 into root 2. It will give 3.89. 3.89. If you have any doubt, you have to comment with uh, your doubts with the timestamp, right? So we got the Im. So now we have to find omega t. Omega t we already find 314. Omega is already found as 340. Now we have to find the phi. Phi is already found. It's a phase angle between voltage and current. It's 79.18 degree lagging, right? So we can write the instantaneous current is equal to 3.89 sine 314 t minus, what is the angle? 79.8 degree. 79.8 degree. So this is the instantaneous value of current. So after all this, we have to draw a phasor diagram of the circuit. What will be, how it will be the phasor diagram of this circuit if you try. So I take voltage as the reference. So this is the voltage. So the current I is somewhat lagging with the voltage phasor because it's a RL circuit. If it's an RC circuit, it will lead. Current will current will lead the voltage. Now, but it's a, if since it is an RL circuit, current will lag. Current will lag. So how much angle will this lag? It is the phase difference. That's what we found in the previous sub question. It's around 79.8 degrees. Okay, it's the angle is 79.8 degree lagging. So this is how will be the phasor diagram. This is equal to the phi. This is how, if you draw a phasor diagram, it will look like this. So this is a question we have actually proceeded with all the basic concepts that we discussed. So we completed all the 8 part of this question, and thank you.